Leetcode problem 993, cousins in binary tree. So the meaning of cousins is that in real life it is exactly the same. So for example, not 2 and 3 are just brothers, but they are not cousins. But if we want to know something about cousins, let's just check not 4 and 5. Yeah, so they belong to the common grandparents, but their parents is different. So 4's parents is 2 and 5's parents is 3. So they are in the same level but with different parents. So it means 4 and 5 they are cousins. So we're gonna return true. Now let's just use this kind of idea to solve the problem. So what we need to do, we need to know what is the level for each of the node. So for example, for this node 4, it is the level 3, and for node 5, it is the level 3. So the levels are equal. And we also need to know their parent. So for example, node 4's parent is 2, node 5's parent is 3. They are not equal. So this means that they belong to the different parents, and we're going to return true. So we're going to design this kind of a data structure to solve the problem. So for the queue, we're going to prepare a DQ, and inside we're going to prepare the root node, and we're going to prepare the depth because we need to know the level, and we also need to prepare the parent. Yeah. So from the beginning, for the root node, for example, node 1, so the root node's parents, we're going to prepare a noun. Yeah. This just represents there's no parent for root node 1. Now we're also going to check their, so for example, if we find a value, for example, this is for node 4, the value is 4, so we need to record 4's parents and values. So we can use our dictionary because it saves the time. So we're going to use our default dict, and inside we're going to prepare a list. So inside of the list, we're going to prepare two values, parent, depth, and parent. It is exactly like the sequence inside of the queue. So inside of this list, we're going to prepare a depth and parent. And finally, we just need to check the values. So for example, dx and dy with two values, one is the depth and another is the parent. Yeah. Now let's just use this idea to solve the problem. So while q, so we're gonna pop out the node, depth, and parent. Yeah. So from the beginning, the depth, we're gonna set it as, let me think. So for this is the root node, so we can set it as 0 or 1. It doesn't matter because it will have no influence. Even if we set it to be a -1 or 1, it doesn't matter. Yeah. So according to here, the root node is at the depth 0. So we're gonna set it as 0. I think it should be okay. Now we're going to pop out those three values from the queue. We're going to pop from the left side. Yeah. Now what we need to do, we need to prepare the dictionary. So d not.value, and we need to extend two values. So those two values are going to be on the depth and the parent. Yeah. So after we get the two values, we're going to check the left and the right. So if not.left, so q needed to append, and inside let me just use a tuple. So it's going to be the root, it's going to be the node, it's going to be the not.left, yeah, because it will go to the left side, and the depth would plus equal to 1, and depth would plus 1, and parent would be the node. Yeah. So this node.left is child, and this node is the parent. So this is the child, and this noun is parent. Yeah. And similarly for not.right. So if not.right, so q need to append not.right and depth. So the depth is gonna plus 1 and the node. So finally, we just need to check the dictionary. So dx 0, it means the depth. It's going to be equal to dy's 0, and dx 1, it is the parent, should not equal to dy's parent. Yeah, so this is going to be the entire code. Now let me just run it and submit it to check. Now as you can see, it works. Thank you for watching. See you next time.